Okay, this is going to be chapter 2.1, Simple Kinetic Molecular Model. Alright, let's dive straight into the first question. Question 1 here. Very small pollen grains are suspended, very small pollen grains are suspended in water. A bright light shines from the side. There's a bright light shining from the side. When looked at through a microscope, small specks of light are seen to be moving in random, jerky manner. What are the moving specks of light? You are given an option of either pollen grains being hit by other pollen grains, possible. Pollen grains being hit by more water molecules, even more. Right, water molecules being hit, you can't see the water molecules here. Water molecules being hit, you can't see as well. So answer here is going to be B, simply because you are observing the pollen grains being hit by the water molecules. Alright, then next question here. At negative 39 degrees Celsius, liquid mercury solidifies without a change of temperature. Which row shows whether mercury absorbs or releases energy and what happens to the bonds between the mercury? Now, first and foremost, they already mentioned that it's solidifying, right? Solidifying is basically liquid going into solid state. Now, liquid going into solid state, because it has to be more orderly, right? The arrangements of the molecules have to be more orderly. Obviously, they cannot be absorbing energy. They must be releasing energy here. And once they release the energies, obviously what's going to happen is the bond is going to become stronger, because we know for a fact that solid has a stronger bond. So C is definitely going to be an answer here. Next, Brownian motion is observed when using a microscope to look at smoke particles in air. What causes the smoke particles to move at random? Smoke particles are being hit by air molecules. It could be possible. Smoke particles are moved by convection current. This is not possible. Smoke particles have different weights and fall at different speed. This is not possible as well. And smoke particles hit the wall of the container. This is not possible as well. So A is naturally going to be the answer for this question here. Alright, then after that, look at number 4. Gas molecules striking a container wall causes a pressure to be exerted on the wall. Which statement explains this? When a molecule rebounds, there must be a change in energy. Not possible. When a molecule rebounds, there must be a change in momentum. Definitely logical. When a momentum rebounds, there must be a change in speed. Not logical. When a molecule rebounds, there must be a change. Not logical as well. Only answer is C, boy here. It's basically stating that the molecules here collide against the wall and change in terms of momentum, which ultimately induces the pressure inside as well. So a student blows air through a liquid using a straw. This causes the liquid to evaporate quickly and therefore to cool. Which statement explains why the remaining liquid cools? Slower moving molecules are carried away. This is not logical. If anything, it should be the faster moving molecules. The air molecules conduct heat from the liquid. Not possible. The air sets up a convection current. Not logical as well. The molecules with most energy leave the liquid, leaving behind only the less energetic ones, and thus temperature decreases. Question 6 here. The diagram shows 4 open dishes. Each dish contains water at the same temperature. The dishes are different shape and draughts. Which container does the water evaporate the greatest? Obviously, we want to have drought, means to say there is wind, and then we want the surface area to be big, right? So obviously answer is going to be A in this question here. State 2 ways in which evaporation differs from boiling. Now, there are always 2 key differences between evaporation and boiling. And number 1, evaporation occurs at any temperature, whereas boiling only occurs at the boiling point. Alright, this is definitely the first one here. And then the second one is that evaporation occurs boiling will only occur throughout the liquid. Okay. These are the two main differences between boiling and evaporation. Then give one example of a change of state which does not involve boiling or evaporation. Change of state without boiling or evaporation is either going to be condensation or sublimation. And condensation is basically when the air molecules stick to the colder side of your cup and then becomes liquid. Or sublimation is either gas to solid or solid to gas. So you can write either one, condensation or sublimation. Okay. And B. The graph in figure 5.1 shows the variation of temperature with time for a substance that is initially liquid. So it was initially liquid here. Looking at this graph, it changes state, and then here is going to be solid. State what is taking place at A, B, and C. You should say what changes of state, if any, is taking place. So looking at this A here, this is not changing state. It is going to be in the liquid state, right? So this is basically liquid. Cooling of liquid, right, is the cooling of liquid. Then after that, B is basically the freezing point, the freezing part here lah, right, is basically changing state from liquid to solid ma. So it's freezing, changing from liquid to solid, right? Whereas C is basically just the cooling of the solid, right? It's basically more temperature decrease ma, the cooling of the solid. Okay. Then finally here, suggest why the graph is steeper at C than at A here. You can see that here is less steep and here is more steep. Now if you were to analyze this graph here, right, what you will notice is that, number one, for the same amount of time, let's say this is 0 to 10 seconds and this is like 20 to 30 seconds, the range is 10 seconds here, right? You'll notice that there is a less change in temperature here and there is more change in temperature here, right? For the same amount of time, there is more change in temperature C. Now this could only mean that it is much easier to heat up or cool down this particular part here, right? And the reason why it is much easier to heat up or cool down is simply because it has a much lower specific heat capacity here, guys. Having a lower specific heat capacity indicates that it is much easier to heat up or to cool down. So your answer here should be C has a much lower specific heat capacity. Okay, C has a much lower specific heat capacity, right? Then moving on to the next part here, figure 5.1 shows some gas trapped in a metal cylinder by a piston. The position of the piston is fixed. The cylinder is moved from the cold room to a warm room. Explain in terms of molecules what happens to the pressure of the gas in the cylinder. Now when you're moving from a cold room to a warmer room, obviously the temperature is going to increase, right? And when the temperature increases, this leads to a greater amount of energy for the gas, and greater amount of energy means to say they collide more frequently against the walls of the container, producing more force and ultimately getting more pressure. So you're supposed to have that kind of thought process here. So if I were to write this down, it would be something like, as the piston is moved to a warmer room, the energy of the molecules inside the cylinder increases. This causes the rate of collision of the molecules in the container to increase. When a greater rate of collision of the molecules against the walls of the container produces a greater force per unit area, ultimately increasing the pressure. Okay, As the piston is moved, to a warmer room, the energy of the molecules inside the cylinder increases. This causes the rate of collision of the molecules in the container to increase. A greater rate of collision of the molecules against the wall produces a greater force per unit area, ultimately increasing the pressure. And this is how you're supposed to get your 4 marks, guys. Alright, now looking at question B here, the piston is now released. It moves to the right and finally stop. Right now this piston is released, it moves towards the right, so the new position will be here, and then it finally stops. Explain these observations in terms of the pressure and volume of the gas cylinder here. So you're supposed to mention why does it, what's going to happen in terms of pressure and volume now, right? So if I were to write this down, I'll say something like, as the piston moves towards the right, volume occupied by the gas in the cylinder increases. This causes the molecules per unit area, per unit volume to decrease, ultimately decreasing the pressure in the cylinder. Okay, as the piston moves towards the right, volume occupied by the gas in the cylinder increases. This causes the molecules per unit volume to decrease, means to say there's less molecules per unit volume, right? Ultimately, it's obviously going to decrease the pressure in the cylinder. Okay. Now after that, a balloon contains a fixed mass of gas. Explain in terms of molecules why the pressure of the gas increases when the volume decreases. So basically when you compress any balloon before, right, you'll notice that there is a greater amount of pressure. It's basically the exact opposite of what we mentioned just now. When we compress it, the same amount of air molecules are going to occupy a much smaller volume and thus collide against the wall more often and thus increase the pressure. As the balloon is being compressed, the molecules inside the balloon occupy a smaller space. This causes the rate of collision against the walls of the balloon to increase, ultimately increasing the pressure. Okay? And then the final question for this part here, the initial volume of the gas is 500 cm3 at pressure 1.1 times 10 to the power 5 pascals. The volume is reduced to 200 cm3. The temperature is kept constant. Calculate the new pressure. This one here is definitely going to be Boyle's law, right, which is P1V1 is equals to P2V2 here. So it's basically going to be 1.1 times 10 to the power 5 multiplied by 500 cm3 is equals to P2 multiplied by 200 here. So if you press this into your calculator, where's my calculator? 2.75 times 10 to the power of 5 pascals. Okay, which is in line with what we know now, right? A decrease in volume is going to increase the pressure. 2.75 times 10 to the power of 5 pascals here. Okay. And finally, the last question for this part here, the volume of water in the puddle is slowly decreasing. Describe how 2 changes in the weather condition could affect the rate at which the puddle dries. Change number 1 is obviously to have more wind, right? When there is more wind, what's going to be the effect? The puddle will be less humid, and obviously what's going to happen is evaporation increases, right? And the second change could be also to be more sunny, right? It is like, so maybe like a hot hot weather, the effect is going to be the puddle of water has a greater temperature, evaporation increases. Okay, so this is how you're supposed to answer this part here. Moving on to the next exercise. A cylinder with a tap contains a fixed mass of gas X, so there's gas X here. The gas is contained by a piston which can move freely towards or away from the pipe, from the tap. So this thing here could move either towards or away from the tap. When the tap is open, the piston moves slightly towards the right and towards the tap here. Right, so when this thing is open, this thing is going to move towards the right. What can be deduced about the pressure of gas X? Obviously, what's going to happen is if this thing is moving towards the right, it means to say the pressure here is higher, right? Higher than the atmospheric pressure here, right? That's why this thing will move towards the right to be equilibrium. Once you open it already, the pressures must be the same. Only then will this piston stop, right? So looking at the answer here, before opening, obviously it's supposed to be more than atmospheric pressure, so it's either C or D. After opening it, it is definitely going to have the same atmospheric pressure because it does not move anymore, right? Then liquid evaporates from a beaker. What happens to the temperature of the remaining liquid, and how does the temperature change affect the rate of evaporation? Obviously, everyone knows that the temperature is going to decrease when evaporation occurs, right? And the rate of evaporation is going to decrease as well because temperature is one of the factors that affect the rate of evaporation. Okay, then next part here, which statement about boiling and about evaporations are both correct? Boiling takes place only at the surface, no. Takes place at the surface, no. Takes place throughout the liquid. Evaporation obviously only takes place at the surface, so C is the answer here, right? Then next question here, diagram 1 shows the apparatus being used to observe the smoke particles. Diagram 2 shows how the smoke particles move randomly. So there are smoke particles and also air particles inside. Why do the smoke particles move randomly? They are being hit by air molecules, looks logical. They are less dense, nope. They are moved by convection current, they again blah blah blah, no. So only logical answer is A. This is essentially Brownian motion, where the smoke particles are being hit by the air molecules here. Right? Then next part here, the gas in a sealed container is compressed at constant temperature, which graph shows how the pressure of the gas changes with its volume. Pressure and volume are inversely proportional, so only logical answer is going to be donkey here. As pressure increases, the volume is supposed to decrease, guys. Right? Then next part here, a closed container of gas is heated, the pressure of the gas increases. Which statement, pressure of the gas increases, heated. Which statement explains this increase in pressure? The change in momentum of gas molecules trapped in the container increase, logical. The forces of attraction between, no. The gas molecules collide with each other, nope, this doesn't. Gas molecules colliding with each other does not increase the pressure. Only when you collide against the walls of the container is it going to increase. Gas molecules lose more energy, blah blah blah. A is definitely the answer here. A bubble of air has a volume of 2 cm3 at the bottom of the lake, where the total pressure is this amount. The temperature of water is kept constant. The atmospheric pressure at the surface is this amount here. What is the volume? This one here is another Boyle's law. P1 V1 equals to P2 V2. Obviously this is going to be V1 and this is going to be P1. This is going to be P2 here. So 4 times 10 to the power of 5 times with 2 divide by bracket 1 times 10 to the power of 5. You'll get exactly 8 cm here. Alright. Which row shows the relation order of thermal expansion, liquids and gases. Most expansion is obviously going to be gases, least expansion is obviously going to be solid. This is because solid particles have very strong forces of attraction, guys. So they are never going to expand the most. Gases, however, have very weak forces of attraction and thus usually expands more. Okay. Describe the movement of molecules in a solid. They vibrate in fixed position, something that you know since year 9. And then the gas here is obviously free to move about anywhere lah, right? It's totally random free movement lah. Oh, it's 2 marks here. Random free movement with random speeds. Okay. Then figure 4.1 represents an atom, representing an atom by circles approximately the same size. Sketch the arrangement of atoms of solid. So what you're going to do is you're going to use this exact same shape and you're going to sketch it all over here. Make sure to arrange them orderly in a fixed manner. Make sure the molecules are touching each other. Then after that, arrangement of gas, you're going to have random gases all over here. Alright. When you draw the solid, make sure that they are like in orderly manner. Yeah, guys, I'm just drawing it like this right now because I'm drawing with my mouse. Then after that, describe the motion of an atom in a solid. Yet again, it is going to be vibrating at fixed positions here. Right. A helium-filled gas balloon in the room of a house suddenly bursts. State and explain. State and explain in terms of atoms what happens to the helium from the balloon after the balloons has burst. So first and foremost, you're going to say that the helium in the balloon is going to diffuse into the room. Then your explanation is going to diffuse in the room and travel in random directions with random speeds. This is how you're supposed to get your 2 marks, guys. Alright. On a particular day, the atmospheric pressure is 1 × 10⁵ pascals. A bubble of gas forms at a point 5 meters below the surface of a lake. The density is this amount. As the bubble rises to the surface, the mass of the gas stays constant. The temperature is same throughout. Explain why the bubble rises to the surface and why its volume increases. Now there's 2 parts to this. Why it rises is definitely going to do with density, and why the volume increases is definitely going to do with Boyle's law. So you're going to say something like, the bubble rises to the surface due to the lower density compared to the lake water. Its volume increases because the pressure at the surface is much lower than the pressure at the bottom of the sea. Okay. Okay, this is supposed to be bubble rises to the surface due to lower density compared to the lake water. The volume increases because the pressure at the surface is much lower than the pressure at the bottom of the sea. And the final part for this exercise here, state 3 factors that determine the rate of evaporation of water. There are 3 known factors. Humidity is basically how wet the environment is. The temperature is definitely one of them as well. The higher temperature, the greater the rate of evaporation. And finally, the surface area of water exposed. Right, the greater the surface area, the more the rate of evaporation. A person climbs out of a swimming pool and stands in the open air. Explain why evaporation of water from the surface of the person's body causes the person to feel cold. So basically this one here is testing your understanding on how evaporation works, right? You have to understand that when evaporation only occurs because the water on the surface is drawing energy from the water below it, right? Water molecules Water on the surface of the skin of the person. Water on the skin of the person. Water on the skin of the person is going through evaporation. Water molecules on the surface is absorbing energy from the water molecules below it. This causes the more energetic molecules to break off to the surrounding, leaving behind only the less energetic molecules with lower temperature. Okay? Water on the skin of the person is going through evaporation. Water molecules on the surface is absorbing energy from the water molecules below it. This causes the more energetic molecules to break off to the surrounding as gas particles, leaving behind only the less energetic molecules with less temperature. And this is how you're supposed to answer this question here. Then the final part here, which is the 2019 paper. Okay, 6 pages. Let's go. A stationary smoke particle is hit by a fast-moving nitrogen molecule. Which role describes the motion of the smoke particle and nitrogen molecule after they collide? After they collide, a smoke particle is definitely going to move, right? And nitrogen molecule is definitely going to rebound as well, right? A weird question. Yeah. Yep. At room temperature, iron is difficult to compress. At the same temperature, oxygen is much easier to compress. Which comparison of the structure of iron and oxygen explains this? The reason why it's always easier to compress gases is because they have much greater spaces in between them. So iron particles are much closer together, logical, have greater mass, no. Iron magnetized, no. Particles have less kinetic energy, no. So answer is definitely A for this question here. Water in a beaker evaporates when it is left on a bench for a period of time, increasing the surface area and increasing the temperature of water. Each changes the rate of evaporation. Which role is correct? Increasing the surface area, obviously rate of evaporation is going to increase. Increasing the temperature is also going to increase. So D is the only logical answer here. Which statement about evaporation of liquid is correct? The least energetic molecules escape. No, only the more energetic molecules, least energetic molecules. The most energetic molecules escape, okay, from the surface, and the temperature of the liquid decreases. Okay, liquid increases, not logical. Alright, then after that, a liquid turns into a gas. This occurs only at a particular temperature, and the temperature happens throughout the liquid. What is this? Obviously boiling now, right? Throughout the liquid and only a particular temperature. Which role describes the arrangement of the motion of molecules in a gas? The arrangement is obviously far apart. The motion is freely moving, right? Then after that, the bubble of air of volume is blah blah blah. Underwater is depth of pressure, the pressure blah blah. What is the volume of air as it reaches the surface here? Ooh. It's definitely going to be greater than 3, but how much more greater? The bubble at the depth of the pressure is 4 times the atmospheric pressure. The bubble is at the depth pressure of air inside the bubble is 4 times the atmospheric pressure. If it is 4 times, then obviously the only logical answer is times times 4 as well, right? So it's going to be 12 here. Which role compares the separation and the motion of the molecules of a hot gas which those of a cool liquid? Both the gas and the liquid are at the same pressure. The separation of a gas is definitely going to be greater. Separation is smaller than gas, okay, logical. The motion, faster for a gas. Obviously it is faster for a gas because it has higher kinetic energy. And looking at this next question here, volume is this, pressure is this, then after that decreases to this. So this is the first volume, pressure 1, this is volume 2. What is pressure 2 here? It's going to be 25 times 100 divided by 15. 25 times 100 divided by 15, which will give you 166. Okay, so the pressure of gas is the volume of gas decreases to this at a constant temperature. What is the change in pressure? Oh, the change in pressure is going to be this because the new pressure is 67,000 kPa, right? I thought 67,000 pascals, right? So it must be A as the answer for this one here, right? Then moving on, figure 7.1, the small circle represents molecules. The arrow refers to the change of state from the arrangement of molecules on the left and on the right here. Complete the following writing is liquid. Change of state X is from obviously solid into liquid, and then this is obviously liquid into gas lah. Nothing much to explain there. Explain in terms of the forces between the molecules why the gases expand more than solid when they undergo the same change in temperature. This has to do with the fact that the forces of attraction between gas molecules are almost negligible, right? And since they are negligible, then it is obviously much easier for them to expand lah. So you're supposed to say something like gas molecules have very weak forces of attraction between molecules. Very little amount of energy is needed to move them apart. Okay. Then after that, a cylinder of volume 0.02 contains compressed gas at this amount. A valve is opened into the atmosphere. The temperature does not change. Calculate the volume that the escape gas occupies. So yet again, this is simple. P1 V1 equals to P2 V2, right? So it's P1 V1 is equals to P2 V2 here. You're going to get something like 1.8 times 10 to the power of 6 multiplied by 0.012 is equals to 1 times 10 to the power of 5 multiplied by V2 here. Now press this into a calculator. 1.8 times 10 to the power of 6 multiplied by 0.012 divide by 1 times 10 to the power of 5. You'll get a final answer of 0.216 meters cubed. But this is actually not the final answer because the question wants the amount of escaped gas. From this amount to this amount, how much gas has escaped? You're actually supposed to minus them off together, and you're going to get something like 0.216 minus 0.012, which will ultimately give you 0.204 meters cubed. This is the amount of gas that has escaped because it changes from this volume to this volume here, right? 0.204 meters cubed. Then liquid and gases are two states of matter. In both boiling and evaporation, the liquid changes into a gas state two ways, which boiling is different. Yet again, Boiling only occurs at boiling point. Evaporation occurs throughout at any temperature. Whereas the second one is boiling occurs throughout the liquid. Evaporation occurs only on the surface. Okay, very common question with a very common answer. Before injecting a patient, a doctor wipes a small amount of volatile liquid. Volatile liquid here means to say that it is very easy to evaporate onto the patient's skin. Explain in terms of molecules how this procedure cools the patient. Now today, if you think about it, when we apply this kind of volatile liquids onto our skin, right, it actually absorbs a lot of energy and then escapes to the surrounding as gas molecules, right? So you're supposed to yet again mention how evaporation occurs here. So you're going to say that as the doctor applies the volatile liquid onto the patient's skin, the energy from the patient's skin is absorbed by the liquid and goes through evaporation. This causes the less energetic molecules to be left behind and thus cooling the patient's skin. Okay. As the doctor applies the volatile liquid on patient skin, energy from the patient's skin is absorbed by the liquid and goes through evaporation. This causes the less energetic molecules to be left behind and thus cooling the patient's skin. Okay. Gases can be compressed, but liquids are incompressible. Yet again, explain in terms of molecules why liquids are incompressible. Liquids have closed. Liquids do not have spaces in between each molecule. They also have large repulsive forces when moved close together. Okay, a very standard question with yet again a very standard answer. State and explain in terms of molecules any change in the pressure of a gas when the volume is reduced at constant temperature. The statement is obviously yes, they are definitely going to change, right? They are definitely going to change because when you compress them, when you compress a volume, the pressure is going to increase because there is more collision against the walls of the container, right? So your statement is that definitely pressure increases. Your explanation is because the same amount of molecules occupy a smaller space. This causes the rate of collision against the walls of the container to increase, increasing the force per unit area of the container. Okay. A very standard question with yet again a very standard answer. Okay. Then next part here, complete table 4.1 to give the relative order of magnitude of expansion. Most expands the most is obviously going to be gas, expands the least is obviously going to be solid. A liquid is heated so that bubbles of its vapor rises to the surface and the molecules escape to the surrounding. If there is bubbles, then obviously this is going to be boiling, right? At a lower temperature, the molecules escape to the surface. This is obviously going to be evaporation, right? Then not finally, last 2 pages here. The pellet melts when it strikes the target. Describe how the molecule structure of a liquid differ from the solid here. Oh, there's a lot to say. Liquids are free to move about inside the container. Solids are vibrating in fixed positions. You know, they they have stronger forces of attraction between them in solid. You can write anything here that is logical, and you'll still be able to accept the answer. Uh, Starting with the arrangement, solid. Okay. Anything logical, just write 3 points. Figure 3.1 shows a gas container in a cylinder enclosed by a piston. The piston is pushed into the cylinder. The volume decreases from this amount to this amount. This is volume 1, this is volume 2. After the compression is this amount, so this is P2, right? The temperature remains constant. Find the pressure before it is compressed. Yet again, Boyle's law, P1 V1 equals to P2 V2. P1 is going to be P2 V2 divided by V1, which is going to be 20,000 multiplied by 330 divided by 820. From here, you're going to get a very weird number of 8,048 lah, right? It's supposed to be 8048, but you can only write your answer in 3 significant figures, so it's 8050 pascals here, guys. Right? Look at the final question. Solids have fixed shape. Liquid adapt to the shape of the container. Gas fills their container. Explain in terms of forces between molecules and arrangement of molecules why solid, liquid and gas have these properties. Okay, so in terms of forces, right, solid have strong forces of attraction between the molecules, right? They have strong forces of attraction between the molecules. It is their arrangement is orderly. They have orderly arrangement particles. Okay, whereas liquids do not have fixed places. Forces of attraction between molecules in liquid is much weaker. They do not have fixed shapes and are able to slide past between molecules. Whereas gases, forces of attraction is almost negligible. Forces of attraction is almost negligible. They are free to move about in any space with random movement and also random speeds. Okay.